Hello everybody, thanks for coming, and especially thanks for resisting so far. My name is Alberto Revelli, and today we're talking about SQL injection, as you might have noticed. So, just to understand a little bit the level we're starting from. Everybody knows what SQL injection is? Raise your hand. How many of you actually played with SQL injection legally? Okay. We're gonna go a lot of things today. We're gonna see a few tricks, a few techniques that can be very useful for a penetration tester or a black hat, of course, and that can be useful also for a network database administrator to know about. Couple of things about me. I work as a penetration tester for Portcalis Computer Security, which is a company based in London. I'm heavily involved with OWASP. I'm the technical director of the Italian chapter. I contributed to the OWASP testing guide 2.0, and some of you might have heard of SQL Ninja. That's pretty much a very bad coded tool that I happen to have developed in my spare time. So, for the couple of you that might not know what this is all about, this is my 2-slide course on SQL injection. The client web application, the web application talks with the backend database using some parameters that are passed by the client. What happens is that the web application fails to filter input parameters. So, actually, if I introduce SQL code into one of those parameters, that SQL code will actually get to the database server on the back end, will be executed, and I will be able to interfere with the database itself. So, okay, you found a SQL injection. In this case, you have a nice error message that tells you, okay, we have SQL Server, and there is and by putting a single quote, we created an exception. Now what? There are pretty much two main ways. The first thing, of course, is heading to the data. It's a database, it contains data. That data can be very juicy, so let's go for it. There is plenty of research about that. If it's non-blind, we can just start union selecting other tables and just start mapping the whole database. If it's completely blind SQL injection, there are other techniques. For instance, we can start exploiting the fact that error messages might be different, or web pages might be different depending on the values of a data, and so we can actually use inference-based techniques. If you want to know about this bit, there is a great paper from David Litchfield that explains in very good detail. And of course, we can have a lot of fun with that. We can find very useful data, very nice data, username, password, credit card details. There's a lot of things we can target. And there's also a heap of tools to choose from. This is just a few that came to my mind when writing this slide, but there's plenty of toys that you can use. Pretty much all of them are free. So, and that's nice and good, but I like to have more fun with the underlying operating system. The fact is that modern DBMS are very powerful applications. They're not just managing data anymore. They provide a lot of instruments that actually talk with the underlying operating system, and so that's something nice to work with. There's been some research done, not as much as a data extraction part. You need administrative access in order to actually talk in a sensible way with the underlying database, but there are several attacks on pretty much every database. There are at least a few ways to actually at least attempt to escalate privileges if we're not DB admin already. And again, we can have a lot of fun here too. We can potentially get all the data that we were getting before, plus we have a foothold in the internal network, which is nice. The tools, okay, there's not as much, so actually there's still a little bit of work to do on that. The bridge between the DB and the underlying operating system, of course, is going to be very different depending on which database you're working with. Google will help in finding all that is needed to know to actually run commands in every major DB technology. There's a database hacker's handbook that also provides very good resource on that. There are a few typos here and there, but provides a very good starting point. For instance, MySQL on Windows, it's possible actually to inject a full DLL in by putting the binary of it and putting it in a file, create a function that uses that file as an external library, select the system in this case, and you can start running command. DB2 also, you create a procedure and you can start running command as well. Of course, the syntax, as I said, varies a lot. Oracle provides lots of different ways depending on the version, but it's such a powerful database with a lot of ways to actually play with it in nasty ways. For instance, in this case, I'm using the DBMS scheduler in order to create a job, and the job action contains the command that I want to execute, and then I just run, and it works. Today we are focusing on Microsoft SQL Server, and why? Well, it's very easy to issue commands on Microsoft SQL with Microsoft SQL Server. You have XP command shell that is there. It's enabled by default on 2000 for administrative users. If it's been disabled and you attain administrative rights, you can re-enable. You can create a new one. It's very easy to play with. And usually the typical pattern when it comes to exploiting this kind of vulnerability, one creates an FTP script which tells to actually download netcat from our computer. We run FTP taking that script as an input, and the second line XP command shell FTP -n-s with the script that you want to use as input, and then we just put netcat listening to on some port, and we just connect to it. It's fun. It's been known for years, but okay, let's move to the real world now. First of all, our input might be sanitized. There might be some web application firewall that actually makes things a little bit more complex. Second point, our queries might be run with low privileges, so we're not administrators. And it's very likely to be a firewall between us and a database, so it's not that easy actually to start a connection. And in the end, we don't just want to work with the DOS prompt because it's not very powerful. I mean, it's nice. You can run commands, but we really want to do something a little bit more fun. So let's start with the first bit with a few hints about how can web application firewalls can be, in some cases, be bypassed. So, for instance, one of the major pattern matching techniques is just, okay, let's look for all what we know is malicious queries, potentially malicious SQL code, and just filter. So let's say if we filter XP _SP_, so we are pretty much sure that nobody will actually be able to run any store procedure in our database, and that will actually filter the commands that you see down there, this kind of a local ping. However, how about the following? What if I declare a variable, put that weird string in it, reverse it, and then execute it? At this point, the pattern is not matched, and it works. This is a very trivial example. Of course, a real pattern matching engine will do a lot more. So, for instance, will not allow select, will filter single quotes plus all what we've seen before. So what happens? We take the same query that we did before, and character by character we encode it with its ASCII value. We end up with that string there. That can be quite useful in this scenario. We declare another variable. We set this variable with the encoded value of the command that we want to use, and then we just call exec on that variable. That'll work. That'll work fine. And notice that there is no XP command shell, of course. There are only three SQL commands: declare, set, and exec, which is they're very likely to work, as they're pretty much almost like real words. They're quite unlikely that they're going to be filtered. And no single quotes. The whole query has no single quotes at all. So if you, for instance, find a numeric field that you want to inject, this is going to be very handy, because you don't need any single quotes even to run any SQL command that you like, because you can encode any possible query like that and just put it between those two commands, and that'll work. We don't have to stop here. We can add even more complexity. For instance, you might want to put some comments as separators. I've seen a few occasions in which it was not possible to inject spaces, and so we just had to add a comment. Thank you. Sorry. Thank you. So we just substitute spaces with comments, and it works. Random case, random URI encoding. And to give you an example, the previous query actually becomes something like this. And quite hard to do any pattern matching in there. So if there is some web application firewall vendor that comes to you and say, look, my product has a varied uses pattern matching and is able to find any possible threat, be careful, because it's quite a danger. It's really a hard problem to actually be able to filter every potential threat. So let's say that we actually found a way to evade the application firewall in between, and we want to escalate privileges. There is a nice command in transactsql, which is openrosette, which is used to access remote data from an OLDB data source. Basically, it's used to run a query from one database to another. Need, of course, proper credential in order to access it on the other database. Is accessible by all users on SQL Server 2000. This is not the case on 2005, but we still see a lot of SQL Server 2000 out there, so it's worth playing a little bit with this technique. It's very easy to use it to brute force the SA password, as we will see in a second. And there's also a very nice thing, the fact that on SQL Server 2000, passwords are actually case insensitive, which makes things a lot easier. So, how do we use openrosette? We just create a select from openrosette. The address there, the address there is empty, meaning that the connection will be performed on the local machine. I will specify the UID SA and a candidate password I can find wordless on the internet. And then I'll say, okay, if as a command to execute, just wait for 30 seconds. I need to escape, of course, the single quotes here. And one last thing to remember, you need to put a select one, because openrosette expect to receive at least one column. What happens here is that I'll just starting one password after another, and when the query actually takes 30 seconds to execute, it will mean that that was the right password, because it means that the openrosette connection was successful and the command inside was executed. Very old attack, again, it's been known for years. Can be improved, and I will say how. A few caveats. Mixed authentication needs to be enabled. If you have Windows-only authentication on the database, of course, it won't work. Mixed authentication is pretty much the rule out there, as far as I can tell, which is a very bad choice, because it means that the SA password is actually passed in clear text on the wire between the application and the database server. This thing works, of course, only if the SA password is a dictionary word. If it's not, it doesn't work. And the big problem with this technique is that we'll likely need a massive amount of connection that will create a massive amount of log entries, both on the web server and the DB server. So we want to change the approach. The original idea was even back in 2002 from Chris Anley in his paper, More Advanced SQL Injection. The idea was to inject a query that does the brute force on the database itself. So just one query that starts running locally, trying all passwords until it finds the right one and makes the privilege escalation. So the brute force is actually performed using the resources of DB server, which I think is kind of cool. The problem with that is that, curiously enough, Chris Anley didn't release the whole code. And to the best of my knowledge, no public tool actually implemented this technique. Again, I might be wrong here, but never seen anyone. So I decided, okay, let's give it a try, and while we are here, just make it also a little bit better. The original code, what it does, actually checks whether the password is correct in every iteration, which means that if we have like thousands of passwords that are tried, it will every one of them will actually make 2 queries, which actually will double up the time that we need in order to actually brute force the password. So what I did is actually, okay, I split the task and make only one check at the end of each chunk. I split the task in smaller pieces so that every password in each of those pieces is actually checked only at the end, and that speeds up the whole process a lot. So how does it work? We create, okay, this is an example with a 2-character password. Of course, it's going to be tried first 1 character, then if it doesn't work 2 characters, then 3, then 4, and so on. This is the code for 2 character. We start by declaring the variables that we need. P will be the candidate password that we're going to try. Z is actually a single character that is used to build a candidate password. S is going to be the charset that I'm going to use. A and B are going to be cursors that will actually move on the charset to actually construct the candidate password, and Q will actually contain the query that will be run. So we start setting up the charset. You see A, B, C, D, etc. numbers, a few alphanumeric stuff, and punctuation characters. We set up A and B to 1, which means that we'll start by pointing both at A, and then we make a double nested cycle. So while A is lesser than 37, and begin while B lesser than 37, begin, and that will make sure that every single password of 2 characters will be actually tried. If we were trying with more passwords, we just need to nest more cycle. What we do, we actually create the candidate password. All this code from now on is going to be executed for each of those cycles, obviously. So we actually make substring of from the charset. If it's a single quote, we need to escape it, otherwise things would break. And then we add the character to P, which is our candidate password. And finally, we create our query, which is again openrosette. UID address is left empty. UID is SA. Password is going to be created with P, which we've just created. And as a code to execute, we launch a store procedure, which is actually sp add server role member, that says, okay, that is used to change to add users to specific groups. In this case, we take system user, which is the user that we are running our queries as, and we add it to sysadmin. Then we say master xp result set, telling you, okay, now execute the query storing the variable Q, and then increment the values of the cursor and start all over again. When the whole code is executed and the cycles are finished, I just check if at the now it's my user is in a sysadmin role. If it is, I escalated privileges. If I didn't, I will just try a longer password. This is a screenshot from an actual attack. We have time at the end, I have other demos in store, but we might also do this demo on a live system. I have a VMware running here. We can play a little bit with that. So for instance, in this case, we said, okay, up to 4 characters. We decide to use a very simple charset, so only letters and numbers. And then SQL Ninja will start actually trying password of different lengths. So 1, 2, 3. When it arrives to 4, in order to actually split the chunk to sensible ways, it actually splits it so that only the last 3 characters are actually changed in a given execution. That's because, well, for one reason, we don't want to have to wait a lot. Already a 4-character password might take quite a while actually to go through the whole execution. And maybe we have found the password at the very beginning, and we don't want that query to execute until the end. Also, another problem is that during this attack, the CPU of the target database servers is very likely to jump to 100%, and this might not be the case very nice if it's a live application. So we might want to be in control and be able to interrupt the attack if anything goes wrong. The chunked approach actually allows us to do that. If we just hit Ctrl+C, only the current chunk will be completed, and then the attack will stop. The cool thing is that if the SA password is not a dictionary word, this attack will still work. And we have a very small footprint in the logs because we're going to use very few queries to do all this. Of course, the trade-off is that the very high utilization of the CPU might trigger some alarms. So be careful on the target you actually use this tool for. So again, let's say that we successfully evaded the web application firewall. We escalated privileges. Now we want to start doing something a little more fun. We want to, okay, we are administrators, so let's start doing stuff. And we want to, for instance, to upload executables so that we'll be able to run our code. Of course, if as we've seen before, if outbound FTP works, just go for it. It's simple. If you have a local SQL server that can be contacted by the target SQL server, you can transfer executable with BCP. That's a very neat feature that SQL Server has. One point here: I'm not trying to bash Microsoft in here. I think that they did a great job with SQL Server 2005. I'm not here trying to say that SQL Server is more vulnerable. What we'll see from now on is actually caused by some mistake of a sysadministrator. And again, just that Microsoft SQL Server happens to be the one I did more research on. Coming back to the BCP, it's fun to see that, of course, it's supposed to work on port 1433, but by playing with the registry, and we can do that with XP regwrite, an undocumented store procedure, we can also change the port, so if there is a firewall in between, we can still bypass it. The problem is that we might not know the right port number. So if you want to upload, for instance, netcat to find an outbound port that is enabled, we have to take a different approach. And we get some help by the old MS-DOS debugger, that old debug.exe, which probably you guys haven't used in years. It's the old debugger of Windows is actually MS-DOS is actually 16-bit, but it's still shipped with every version of Microsoft Windows. And what is nice is actually scriptable, so it's actually can be used with a script that we can upload to the DB server. The commands that are interesting to us are, well, n, which specify the file to debug, in our case the file to create. Register, which actually writes a value on a specified register. F, which actually fills the memory with the memory space, the memory segment with a specified value. E, which writes a specified value into a specified memory address, and then W, which just writes the memory address into the file that we specified. What happens is that we can actually represent every executable that is up to 64Ks as a DebugX script. So, for instance, getting back to netcat, this is the beginning of netcat with the header of the P executable, so for D5A90. We can represent this as a debug script in this way. Well, we create first the name of the file that we want to create, in this case NC. It's .tmp for a reason that I'll explain a little bit later. So we specify the file that we're actually creating. We specify the dimension of the file, and we put it in the CX registry. Then we fill all the segment with null bytes, and then we finally write in the only the bytes that are different from 0. We could just go all the way and one after the other write every one byte at a time. This just happens to create the most compact scripts. So we just write in memory every byte that is different from 0, recreating the image that was the original netcat.exe. Finally, we write the file to disk, we quit the debugger, and netcat is going to be there in executable form. Couple of caveats. DebugX actually doesn't like to be used for executable files. If we had named that file nc.exe, DebugX would actually complain about that, which is why we name it as nc.tmp. So we just name it as something different. We write it on disk, and then we'll rename it to nc.exe, and that will work. It's actually very easy to create those scripts in an automated way. Last SQL Ninja release, which I hope to release officially sometimes next week, actually includes a Perl script that does that. Again, it's all automated, and another trick is actually that we can use actually try to upload to the temp directory, because we will very likely bypass any write restriction that other directories might have. The only one limit I was telling you about before is the size. We are limited to 64 Ks because, of course, we're dealing with a 16-bit debugger, and the register only can store that value. So we are limited for now to very small files. But that's not a problem, because we will see how to bypass this limitation too. So how does it actually work? What I do, I start using XP command shell to actually echo those one line at a time of that script to this proc.scr, stand for script, and one after the other I just write the whole script into that file. I finally call debug on it, taking as an input proc.scr, and when the command executed, I just rename it from proc.txt in this case to proc.exe, and proc.exe at that point will be on the database server. The funny thing is that we are actually creating some binary on the other side, but we are just actually using ASCII traffic from our box to the database server. So it's actually less likely to be spotted. It's actually kind of a very elegant way, in my opinion, to actually upload things. When we upload netcat, at this point it's quite easy to start using it as a port scanner. So for instance, trying to scan back to our box to see if there is actually a port that is open on the firewall, so that we can be contacted in that port and spawn a reverse shell. So, assuming that we successfully uploaded our executable, let's go to some other potential things I want to do. At this point we have administrative rights. At this point we can execute commands on the DB server. At this point we can upload a new executable file. The problem is that sometimes even when we have netcat on the other side, we cannot find any suitable port, nor TCP or UDP. Either everything is blocked, so we need to find another way to actually get the results of our commands. The only alternative at this point is actually to create a tunnel. We need to find a protocol that, by piggybacking on some other machine, is actually able to get the traffic out of the target network and relay it to us. Of course, there are different solutions here. First one that usually comes to mind is HTTP. We need to find an HTTP proxy on the net, and we could use netcat actually to start scanning the whole segment for port 80, 8080, 3128, and hopefully it'll be able to find something listening. The problem is that a proxy might not be there, and even if it's there, it might need credentials authentication. Since we are very likely to run as a system, it's very hard even to look in the registry at that point and try to find if there are some credential cached by Internet Explorer. If there are credentials needed, we are pretty much it's very hard to find a way to get out. We would need to actually import, find the local users, import their areas of the registry in the current in the registry that as we see it, look in there for the password. It would be kind of a mess. So I prefer to let it for somebody that is more gifted than me. Another possibility is actually use SMTP. There is XP send mails extended procedure on SQL Server 2000, which became database mail on SQL Server 2005. And what we can do is actually upload an executable that will start looking for some port 25 TCP that is open and try to send mail through that. It's quite easy to implement. The problem is that it might be a little bit slow, because you run a command and you need to wait for an email. You run another command, you wait for an email. Not very interactive. So my choice actually fell into DNS. To use DNS, we only need that the target DB server can resolve external domain names. It doesn't have to be on a direct connection on port 53 from the DB server outside. It just need to be authorized to ask their own local DNS server to have the DNS server resolve the names for them. And if that is the case, which it usually is, then we can try to tunnel our data inside the DNS protocol. This is not really a new idea. I mean, Dan Kaminsky did a brilliant job. If you've seen his presentation at Black Hat a couple of years ago, 2 or 3 years ago, he was actually able to stream audio and video through on DNS traffic. So it's actually got a lot of potential and an acceptable bandwidth also, if the network is actually quite fast. Also, other researchers apply the same concept using DNS in order to extract data. Aaron Meir, Marco Slaviero, and Patrick Carlson did a brilliant job in doing that. The cool thing is that the way they implemented it, they don't even need administrative privileges. That's because they actually look for the data. They don't look for actually executing command. So they just take the data from the tables, append this data to a host name, creating a host name with the domain that is under the control of the attacker, and then uses there are a few store procedures that can be used can be used by any user, and that will actually try to resolve that host name, and that will be a very easy way to actually get the data out. If you want to give it a try, SensePost guys actually developed Squeeza that was presented last year at DEF CON, and it uses exactly this technique. But again, just to extract data. Here we're trying to actually tunnel commands. So what we do, we create this remote agent that we call dnstun.exe that will do the job for us. We upload it using the DebugX technique that we've just seen. At that point, we can use SQL injection to run the command that we want. In this case, for instance, xp command shell, and the command will be dnstun.exe. We have to specify the domain that we control. Of course, our box needs to be the authoritative name server for that domain, because that's what the box that will be contacted by their DNS server in order to perform the resolution of the name, and then the command to execute. For instance, in this case, dir c colon. Our agent, so DebugX, takes the command, uses create process to execute it, and by creating a pipe, is able to intercept its output. The output of the command at that point will be encoded in a slightly modified base 32. Base 32 because the characters are all valid in a DNS request. So for instance, the results of that DRC might be something like that, a very obscure string that will actually contain the results of that command. At that point, the command will be split in pieces if it's too long. A hostname can contain up to 255 characters according to the RC, as long as every token is actually no more than 254 characters. Yeah, as long as the token is actually no more than 64 characters long. So depending on how long the output is, we might have to split the output into pieces, and then for each of them, call getHost by name and wait for the database server and the DNS server of the network to do the rest. The request will be received at DNS server. The DNS server will forward the request to the authoritative DNS server for evil.com, which is our box. Our box will have a fake DNS server listening on port 53. It will get the request, answer with some random IP address. Really do not care about. We just need to get host by name to exit cleanly. So we just answer with some IP address. Take the command output, decode it to the original way, and visualize it to the user. Graphically, this is what happens. The attacker, through SQL injection, contacts the web server, launches the command. The command is executed. The output of the command is then encoded and resolved, and resolved by getHost by name. GetHost by name will contact the DNS server, trying to resolve the encoded output evil.com. The DNS server will look on a root DNS server what is the IP address of an authoritative domain server for evil.com, and it will be answered that is actually our IP. And at that point, we will receive the encoded output. A little bit more of detail about what we receive. Here is an example of the output we receive. In this case, I limited the host name to 64 characters to make it fit in the screen. But of course, this will reduce a little bit the bandwidth of our tunnel. Of course, it's better if you do this kind of attack, it's always better to use a very long host name, unless you have a kind of a feeling that might be spotted. You know, seeing a machine that all of a sudden start resolving like hundreds of host names with these very long names might be seen as a little bit suspicious. So what do we have here? First of all, we have a packet counter, because of course it's not necessarily true that all the requests that we reach are going to be in the same order as they were transmitted. So we need to append a packet counter that allows us to reorder the packets if needed. This will be the actual payload encoded in this slightly modified base 32 format. We also need a flag to tell us when we receive the last packet. So for instance, in this case I use 8, which is not part, of course, of the other of the payload charset, in order to tell my fake DNS server that he should expect some more packets. And it's actually 9 when it says, okay, fine, that's enough, and you have all the data. And final thing is that the whole thing is actually streamed, meaning that when if the command is actually has a very long output and it takes time to actually be executed, our agent will actually start intercepting the input right away. We'll start buffering and just sending over to us immediately. So even if the command will take long to execute, we'll start seeing the traffic coming over immediately. And finally, we have the evil domain that we're using, of course, to use for having the traffic sent to our box. And for instance, this is actually what happens in a real case. All the garbage that you see in the back was actually decoded into the output of the command, which is in this case is ping the local host, but it could be at the point anything else. And so what happens is that we have this tunnel working. Is half duplex at the moment. I mean, we send the command through SQL injection and we get the result back through DNS. It would be quite easy actually to change it and make it a full duplex DNS server. So we actually a full duplex DNS tunnel. So we only need to send the first command, and at that point we just have a tunnel between us and the remote machine, and we can start issuing command and getting the responses in the same inside the same tunnel. Finally, do we have time? Yeah, plenty of it. GUI access, which is actually probably the best and last part of the presentation. Again, as I was mentioning before, the DOS prompt is nice, but not very powerful. It's quite tricky to use it, to use the remote box to actually attack other boxes in the target network. there are very few utilities present, and so we will need to actually start uploading other stuff in order to do something useful. We might not even have like the who am I command, so we just in order to know what's the name of the house we're on, we would need to upload other stuff. So it's really, yeah, it's nice to show on a client, but it would be nice to do something more powerful. So what about uploading a full VNC server and having that VNC server to contact us? The problem, of course, is that, well, the VNC server would give us full GUI access, but such a file would be a lot bigger than 64Ks. So we need to bypass this limitation to start with. Of course, since we are assuming that we have an inbound or outbound TCP port available, we could simply use netcat to upload our executable at this point. We start off by uploading netcat. We probably did already in order to find which port we could use. And then we can use netcat actually to transfer a file on that port. In order to do that, we would have to pack our VNC server as a standalone executable. But the problem is that would leave quite a big footprint on the hard disk. We would have to transfer quite a big file. And also, if we don't actually do it as a standalone executable, but we actually upload the whole installation package that we scripted it so that it actually works automatically, we'll leave even a bigger footprint because we are actually installing software on the remote machine. So how about we upload a small executable that just opens a socket, and then we inject a library into that. That would work. I mean, on Windows machine, remote library injection is a very well-known technique. We just have to take a DLL. In case somebody doesn't know, DLL is just a library that implements some functions that are used by different applications. Usually a program, when it starts, it loads the DLL, but it's not really a big limitation. It's possible to inject a new DLL into an already running process. There are actually two ways to do it. We can actually upload the DLL on the disk and then have our file read it, or we can actually do everything in memory. So we just send the DLL across the network, we put it into memory, and then we have it loaded by our executable, not touching the disk, which is actually quite cool because it will help us to bypass any kind of antivirus depending on what kind of DLL we are injecting. And again, yeah, we can bypass antivirus, but I mean that sounds a little bit familiar. I mean, I'm sure that a lot of you already figure out, okay, but we have something already that does that, right? We actually have. I mean, we can use Metasploit that does exactly that. For the ones who do not, Metasploit is an open source exploitation framework. Provides lots of exploit payloads. It's very easy to craft your own exploits depending on the exact attack scenario. It's not considered usually a web application attack tool. It's all usually used for infrastructure, network level kind of attacks. But I mean, who cares? If we can use it here, that would be nice. And Metasploit gives us exactly what we need: a VNC server packed as an injectable DLL. So we don't have to reinvent the wheel here. We can just use something that has been done and does a really brilliant job to actually exploit this SQL injection in a kind of a different way from usual. So a little bit of again about how DLL injection works. It's not a very simple technique, and it only by itself it would probably deserve a whole talk by itself. But here is a very short and extremely oversimplified description. Basically, our first executable that we call a stager loads all the needed libraries and resolve the required symbols that are needed in order to talk on the network and load a DLL. Opens the socket to our machine using a direct or reverse TCP connection, so it can work both ways depending on the situation and the firewall in between. Using virtual alloc, it will allocate a segment of memory for DLL. Using receive, reads the DLL from the socket and writes it there. At that point, it hooks a certain number of functions the functions that are needed to actually load the library, because the operating system expects to actually find the library on the disk. So we need to hook those functions so that when our DLL is called, the operating system doesn't go and look on the disk, but actually start reading from the memory segment that we previously allocated. At that point, we can just load the DLL as if it was a normal one, and it will just take the DLL from the memory segment and load it in the memory space. And at that point, all the functions that are exposed by that DLL can be used. There is a problem though, and that's the last problem to make it work. It's DEP, which stands for Data Execution Prevention. It's a feature that has been introduced with Windows 2003 Server SP1 and also on XP SP2 actually. And basically what it does, it disallows the execution of code in areas of memory that are not marked as executable. The whole point here is actually to protect the machine against buffer overflows attack, mostly all kind of memory corruption based attacks. Because what usually happens in this case that the malicious code, the shell code, is written on some data segment, and then the program the exploit tries to execute it. And that is actually was thought to avoid this. If some memory space is tagged as to only store data, and we try to execute code there, the program will just crash. It comes on in two flavors: software-based and hardware-based. Software-based is actually enforced at compiler level, and so it's really not very much interested here, because the executable to protect must be actually recompiled to use it. So it's not really very common scenario. What we are interested in is hardware enforced DEP, which is actually a lot more effective, because it utilizes features that are provided by the processor itself, which makes exactly that execution prevention work for any executable on the machine, and making it so that it will not be possible to use the technique of DLL injection right away. That's because Metasploit, when actually tries to maps the memory for the DLL, also marks it as executable, and at the point DEP will kick in and crash our exploit. So what will we do here? Well, there's a little bit of research also on how to bypass DEP. There is a very nice paper from Escape and Skywing that's been published in 2005, so it's not very new actually. They use NT-set information process to actually set memexecute option enable, which is a flag, to set it to a value that says, okay, this memory can be actually considered as executable. The problem with this technique is that you need null bytes in it, so it might not be suitable for in a real-world exploit if you're actually exploiting a string, for instance. An alternative, which is a little bit more flexible, actually just directly returning to some NTDLL code that will do the same thing with actually calling explicitly NT-set information process. It's a nice technique, it works, but SQL Server, luckily for us, or unluckily, depends on which side of the fence you're in, provides with a much easier way. A little bit of background. There are actually 4 configurations for that. It can be always on, so is used for every executable on the machine. Always off, so it's actually disabled. Opt-in, which means that is used only for system executable and libraries, but is not used for other executables unless they are actually listed, specifically listed to be protected, which is actually the standard, the default value for XP, XP2. And the last value is actually opt-out, which means that all executables will be protected unless they have been whitelisted. This is the default one on Windows 2003, so that's Windows 2003 is SP1 is shipped with this setting, and the whitelist programs are listed in the Windows registry. So what we can do is actually quite simple. We just need to find the right key in the registry, whitelist our executable there before actually injecting the DLL, and hopefully it'll work. And we use XP reg write for that. We also use XP reg read to actually understand what's the setting. I mean, if we find out that that has been deactivated, we don't need to go through all the pain. We just launch our exploit. But if with the XP reg read, we can actually check the exact setting. And if we see that needs to be our executable, which we call the stager.exe, needs to be whitelisted, we just need to use this, inject this query. What we do, we create a temporary table which we called rog with just one column inside. We put into that field the full path of our stager.exe, because we need to know the full path of our executable in order to successfully whitelist it. So we take echo temp, which will tell the directory on in which it was stored, and then we set b as that value plus stager.exe. B will contain at that point the full path of our executable. At that point, we call xpreg write on software Microsoft Windows NT current version app compat flat layers, and we set that a registry key with that the full path of our executable. At that point, we drop our temporary table, and if it works, at that point the executable will be able to run without having to deal with that. So, putting everything together. Are you tired? No? Okay. Putting everything together. We might need to brute force the SA password and escalate privileges. If that was successful, we upload netcat and find the port that is allowed by the firewall, either inbound or outbound. We need a port, of course, to do that. We could actually do this also on DNS. Well, not probably with a full DNS server, but a full VNC server, sorry. But Metasploit, for instance, provides Meterpreter, which is another tool that can be used to have a lot more power than just a command prompt. So even if this kind of attack can be actually be utilized even if only DNS is working. It's just that we won't have the full graphical interface unless we are happy with a very slow one, and we will just use a Meterpreter. A possible next step. So assuming that we found the open port, we create the stager. The stager will need to create our socket and read the DLL that we will send to it, and then load the DLL and execute the DLL itself with the VNC server. We need to pack the stager in a regular P executable. Of course, it needs to be the stager needs to be in the form of an exe file. Again, Metasploit does that for us very easily. We take this P executable, convert it into a debug script in order to upload it, as we've seen before. Upload the debug script and convert it back to the original executable using debug.exe. We check in the registry the presence of dep, and if it's enabled, we disable it for our executable. And finally, start executable, inject the DLL, and have fun. So it's a little bit of a work in progress. It usually works, and I have a lot of witnesses in this room that actually have seen it working. So in case for the demo effect it's not going to work, I have people that are ready to testify for me. So what we do, can you read from back there? You can? I cannot hear you. Okay. So I have a virtual machine on this box with 2003 server on it, with a very simple application, which is vulnerable. So if we add a single quote here, bang, we have this nice error. In this case, we have the error, but of course, what the whole technique works also for a completely blind SQL injection. So this is the application that we're going to try to exploit. So, okay, we check that Metasploit is actually available on our machine. We ask what kind of payload we want to use. So in this case, for instance, we select VNC. we need to tell SQL Ninja if we are going to contact the executable or the executable will contact us. It's probably going to be more likely the second case. And we decide the port number on which he needs to contact us. So in this case, 1, 2, 3, 4, 5. We can throw in a little bit extra paranoia and encode our payload to make it less detectable by IPS and stuff. In this case, we just go easy, so no encoding method. And we start. So what happens is that we created the stager. It's actually 177 bytes, so it's actually a tiny thing. The payload is converted to a script and then uploaded using SQL injection. After it's been uploaded, it's converted back to an executable using DebugX. At this point, what the tool does, it does a little bit of diagnostic, checking that the executable was actually uploaded successfully, the right dimension. We check at this point if dep is enabled. We use an inference-based technique using wait_for in order to have it working. We disabled in this case because you see dep mark as opt-out. We disabled dep, and hopefully at this point we should have a nice GUI access on the remote database. And yeah, well, yeah, of course. Yeah, of course, that's exactly my point too. I mean, at this point, if you're really keen about getting to the data, you don't need any other tool. Just fire off the SQL Server Manager and access all the data you want, you know. And yeah, that's basically it. Another thing that I wanted to show you is actually the exactly, yeah. Yes, it will, even if at that point I would be very worried anyway, and if I can get a graphical access. Of course, if I run in with fewer privileges, I won't be able probably to start changing password or to the users. Actually, have complete local administrative access on the machine. But again, it's still a kind of a problem. Yeah.
Excuse me, I'm afraid I have to stop you right now because we are a bit late. So
yeah,
all the questions can be answered during the coffee break.
Yeah, no problem. Just one. Can I have just 1 minute for the last?
Well, hopefully.
Huh?
Okay, hopefully you can.
Okay,
well,
basically.
That's 1 minute.
It's just wanted to have you guys have a look also the DNS tunnel to see actually it works too. So what we have here is a Wireshark listening. So I call it D, and let's say I do dir, and what I have is here is actually the directory of Windows WinNT / actually Windows / System32, and as you can see, it's all DNS traffic. So yeah, that's worth. And
okay, thank you.
I'm gonna skip that last slide. Again, feel free to try this at home, hopefully in a legal way. And all the everything that you've seen is actually implemented in the last version of SQL Ninja. That again, it should be released officially next week. If you are really in a crunch with a penetration test and need it like now, just drop me an email. I will send you the last beta. Otherwise, just wait a few days. It's gonna be there. Thank you very much.